Good evening and welcome to week 7 of the Fundamentals of Micro and Nanofabrication. The course instructor is Professor Susuban Awasthi and Professor Sankar Selvaraja from ISC Bangalore and the PMRF teaching assistant Vikas Pandey from IIT Jodhpur. This is a brief about me, which includes the Google Meet link, YouTube channel, and my contact details in case you want to contact. So, in continuation with the topic that we were covering, we'll be continuing the topic lithography, in which we will be talking about optical lithography. So, in the previous class, we saw that there are three types of lithography: contact, proximity, and projection lithography. So, projection lithography is something that will be covered later in the next week. We will be discussing about contact and proximity lithography. Contact lithography, in short, is a direct contact between mask and wafer. So there is no gap between the mask and wafer. Whereas in case of proximity lithography, a small gap exists between the mask and the wafer. Mask is the pattern that we want to, like a stencil or a fixed pattern that we want to transfer on the wafer. Okay. So let's start with proximity printing setup or proximity lithography. So what are the system components of a proximity lithography? The first and the most important thing here is the light source, that is which illuminates the mask. Second is illuminating optics, and this is required to provide uniform light on the mask. It is not that if we are using a bulb directly or such LEDs or anything, we will not have uniform light throughout our wafer or throughout our mask. So some optics is used, but it is not between the mask and the wafer, but it is before the mask. That is between the light and the mask. There are some illuminating optics that provide uniform light on the mask. Then there is a gap between mask and wafer. This is filled with air or inert gas like nitrogen to prevent any contamination. Simplest one is air, or in some cases, nitrogen is used so that there is no contamination. It is uh, like pure nitrogen is used for that. So, how this proximity printing setup works? The light passes through the mask and diffracts due to the gap. So, if we have a mask like this, we have a pattern, okay, and then at small distance we have our wafer. So light is incident upon it, but due to this gap, small gap, the light will suffer a small diffraction. Okay. It will not be exactly the same that we want that we have on the mask, but there will be slight diffraction due to which this pattern will get a bit smaller. Small imperfections will be there, like slight uh, scaling down of the details of the mask will happen in this case of proximity printing lithography. Okay, so what are the factors that affect the proximity printing? So resolution first depends on wavelength, lambda, of the light, because as I said, it is due to the Rayleigh criteria 2 lambda upon d. This defines the diffraction or the minimum resolution we can obtain based only on the light source. Okay. Then there is second thing, that is the gap d between the mask and the wafer. So the resolution formula for a proximity printing setup is W equals to under root lambda dot d. Smaller wavelength, smaller resolution, that is better resolution. W is about the resolution and lower the resolution, better is the lower this value of W, better is the resolution. As whereas if we have a larger gap, more diffraction, and that will reduce the resolution. So that's why we say that in case of contact lithography, the D is equal to 0, almost 0 or 0.00 something. Okay. So in this case, the resolution is much higher or almost 0, but that's not possible because when we will go to contact lithography, we'll see that there are other factors that determine that. But in this case, lambda is one factor, wavelength, and in case of contact lithography also, wavelength will be a factor. The second important factor is gap. Lower the gap, better the resolution. Larger the gap, lower the resolution, because as the gap increases, the effect of diffraction will be much more. So the practical limitation with this setup is that due to diffraction, spreading and rippling effect of light intensity occurs on the wafer, and so we may, if we are using a gap of like we are using larger gap, in that case we will see some rippling patterns like a shadowed pattern, or a like we wanted a pattern like this, but along with that a fainted pattern like this will also form if the gap is more. Then even less fainted, but then due to the diffraction, such patterns will form. So to so these are some practical limitation. Okay. So the next thing is contact printing process, or hard contact, where there is zero gap. It is firmly connected to the firmly affixed on the wafer. Mask is in the direct contact with the wafer. This achieves higher resolution than the proximity printing. It's simpler because you don't have to take care of what is the gap and these things. So it just have to uh, do a contact, but it can only go in micro scale fabrication. For nano scale fabrication, we cannot use contact lithography. Second is the contamination risk. Since the same mask is being used repeatedly and that also in contact, it can transfer particle and scratches from one mask to another. As well as when it is touching, it will create some scratches. Second is, although we are saying that the wafer is flat, we are saying the mask is flat, but practically there are some differences. Okay. And due to this, there can be some unintentional gap that will lead to some defect, like bubble kind of structure will form over the photoresist. Okay. So there are two problems. One is contamination can happen. Second one is non-uniform contact can be there due to the bowing of the wafer or the mask. So there can be, uh, even if there is some non-uniformity or bowing in case of wafer, that will affect the process, or if there is something on the mask, that will also affect the process. Then comes the problem of over and under exposure. So when we are talking about exposure, what is exposure? First, we need to know this. So exposure, or exposure dose to be accurate, is the integration of light intensity over time. Okay. So suppose that we are putting, say, uh, 6 milliwatt per centimeter square. Okay. And this much light intensity we are using, and we are using it for say 10 seconds. So what will be the dose? The dose will be 60 millijoule per centimeter square. This becomes our dose. It is the integration of light intensity over time. Although I am saying that 6 milliwatt per centimeter square is the light source intensity, but there will be some variation in the first, second, or 10 seconds, it might be less, and then it will be stable. So we have to add up or integrate all of this to get our dose. What happens if we are putting more, suppose that in our case we need 60 millijoule per centimeter square, but by some chance or by some mistake, what happened is that you put 90 millijoule per centimeter square of exposure dose. So this excess energy will cause, since we know that this light will initiate chain of reactions. We have seen about the photoresist in the previous class. So as the light strikes, some chain of reaction starts. So if it is for more time or the amount is more, that chain of reaction will continue beyond our desired value. So if we wanted a pattern like this, okay, we will get a rounded pattern. This rounding will occur at the corners. That is, sharp features will become rounded. Okay. It will not remain straight. Then second is loss of resolution. What resolution we wanted, we will get lesser than that. So overexposure is a problem. What if we are giving some less energy or underexposing? We we had to expose for 10 seconds and we exposed for 8 seconds. And this is something that very commonly happens. Like in case of overexposure, the patterns will be formed. Okay. But in case of underexposure, one very common thing that happens is that it will lead to incomplete development. That means the resist of the like upper layers will get developed easily, but a very thin lower layer will remain on the wafer, and thus will not be able to do our subsequent stages of patterning and these things. So underexposure will sometimes even lead to like stopping the process there itself. And then there will be larger feature size. That is the same thing. In case of overexposure, the feature size was less. In this case, it might become a bit larger because proper exposure till the endpoint has not occurred. Okay. And sometimes two, if there are two features like this very close to each other, they might get merged and form a big box. Okay. So this is due to underexposure. So we have to take care that there is neither an overexposure nor underexposure. For this, all the photoresist that we take, they have some optimal exposure doses given in the dataset. So we have to start with that, and we have to do our calculation based on our light intensity of our setup as, and multiplied by the time, how much we want. Based on that calculation, we have to go for the exposure dose, optimal exposure. So in short, if we talk about contact and proximity lithography, they are simple and cost effective for large features and R&D application. They are ideal for MEMS technology and devices with relatively large feature size. We are talking about large means micro, and that also above say 10, 20 micro. These are fine. But the problem is critical dimension is limited due to the wavelength. The wavelength that we are using is a limitation for what critical or what smallest dimension we can achieve, as well as due to contact lithography, and in case of proximity also, the mask lifetime is limited because we are using repeatedly the same mask, and that is somehow getting in contact with our wafer in proximity, it is in close contact, but not still it is in some contact. Okay, so that decreases the mask lifetime. Now comes the projection lithography. Till here, any doubts, any questions?
No,
Yeah,
clear.
fine. Okay. So we have seen that the contact and proximity lithography we have seen. Now we are coming to projection lithography. It has larger gap and uses projecting optics. So we saw that earlier we had uh, so a lamp or light source, some optics to make it so you can say it is diffracting. So we are making it planar. Then we have a mask on which we have pattern. Okay, and in case of contact, it will be in close contact with our wafer, or in case of proximity, we have the wafer here. But in case of projection lithography, this mask and wafer, there will be some optics in between also, some lenses, lens and maybe optical lens, magnetic field or anything. Such lenses are used, and this is projection lithography. It has some complex lens systems between mask and wafer, and it has large gap, and that's why the problem of mask getting damaged is less. Mask is at a distance from the wafer. There's no contact. Because in between we have lenses and different thing, and mask is not in contact with our wafer, so less chances of damage of mask. So this projection lithography system is of two types: stepper and scanner. So stepper is where entire mask is uniformly lifted in one go, just like projection and sorry, just like proximity and contact. This is projection. Okay, so one complete exposure in one go, or there can be a scanner. Use a moving slit to eliminate only part of mask at a time. Both mask and wafer move to complete the circuit. That means it is like mask, there is one light source and that's not eliminating the whole area. So the mask is moving as well as the wafer is moving together. They are moving to eliminate at different position. It is just like raster scanning, or where we are eliminating one point at a time, not one at the like not in one go. Why is scanner used instead of stepper? Because stepper, you can see that in one go, so there is the timing will be less, and we don't have to go for this moving the mask and moving the wafer. So, but why is this shift to scanner needed in case of proximity? Because uh, sorry, I'm again saying in projection, not proximity. So in case of proximity and contact, there was nothing in between, or sometimes air, small amount of air. So the light source that we were expecting to be falling on the mask, there was very less diffraction, and that's why we expect that the whole wafer is getting equal amount of dose. But in this case, since there are many optics and all these things, there can be some variation in doses. To compensate that, to have a uniform illumination in smaller areas, like very small area and consistent uh, critical dimensions area, we are shifting to scanner where point wise we are exposing each and every point, so that there is uniform illumination or uniform exposure dose to all the points on the wafer. Okay, so as I said, why is this uniform illumination needed? It ensures consistent line width of on the wafer. So it is not that in one part, like if on the wafer, in the central area we have good dimensions, but outside they are merging. They are making a box out of these patterns. The same pattern in the central area is fine, but on the peripheries it's not fine. That we have to counter. Variation in light intensity causes wider feature due to lower illumination or narrower feature due to overexposure. Some area, so if we are saying that the whole area is getting illuminated at once, so and average we are taking, say I am saying that it is showing 7.8 milliwatt per centimeter square is the intensity, but it is not the same at all the positions. It might be 7.8 at these positions, but here in the central area it might be reaching 9 milliwatt per centimeter square. In the outside area it might be reaching 6 milliwatt per centimeter square. If it's like that, then we will have different critical dimensions for different area of our wafer. In the central area, we will get better quality. In the peripheries, we will get lower quality. And if we are talking about bigger wafers, like nowadays 8-inch, 10, 12-inch wafers are used. In that case, the difference will be even more. So the solution is a scanner where we are exposing smaller area at once, one by one. So we are first exposing this area with proper exposure, proper our dose, then the other area, then other area, the other area, like that, a small amount. Okay. So this ensures critical dimensions to be uniform across the wafer. Fine till here?
Yes, yes.
Okay. Any questions or anything you would like to discuss till here? Okay. Yeah.
No,
Yes, yes, you can continue. You are saying something?
no, it's fine. Clear. That's what I'm saying.
Okay. Okay, fine. So let's move to the system components that are there in case of a projection lithography. Okay. So first one is a laser source, and generally in this case, argon fluoride lasers are used. Second is illuminating optics. So this is very similar to the uh, contact and proximity where we have a lamp, or here in this case it is a laser. Okay. Then we have a lens system or optic system to have some uniformity, okay, in whatever area we will be exposing. Smaller area only, but we will be exposing in that. So it has that. Then we have the mask stage. So mask is fitted over this. So we have some pattern and we have this mask. Then we have the projection optics, and this is used for projection and focus onto it. So we have this some optics, and then have the wafer where wafer. Changing this the distance between these optics, find what whatever is the 2x of it, or we want it to be divided by 5 or something, we can achieve this lens optics. Okay, but in this case, one very big challenge, that is alignment, because here multi layers are used. Okay, that means we can't have direct alignment. We have to based on some software alignment, or we have to see through camera and to align with imaging, because this mask whatever is shown, that exactly is not going to be superimposed. We have to take a picture of it, image of it, and maybe multiply it by 2, or divide it by 5, we are going divide by 5. That is done, because in the case alignment is not between two physical, it is between one physical and one virtual. mask or image. Okay. And so in this processing and scale of critical. If it is not properly scaled or properly focused, it although giving dose and everything, the exposure might not correct because the focus point was different. The light was here, so there will be above there. So then be some direction is not needed, and in the duration there will be lessening of dose, or it is forming sabers or forming the wafer. In that is also addiction. Okay. So what are the main alignments of projection lithography? One is translation. So with everything fine, angle, everything, but x, y, or y. So there's slight alignment in x direction or y direction. So suppose that we had making motion that is easier. Okay. So we had a source and like that. This was already made on the way. Then when we went to make a gate over it, gate area. Okay. We wanted at the center. What is that? That gate got this displaced in x direction and obtained a x shifted and y shifted one and the center of this source and drain. But it's shifted x as well as y. So there is translational misalignment. Second type misalignment is rotational. That is the same term, fine, but it got made with misalignment in the in theta direction. It can be significant. Say this was made at 5, but by mistake this the date was 10. So this source and drain features like this, and then the gate that was supposed to be in between that be 10 covered whole thing. So such problem can happen. Okay. There can be some asymmetry happening due to trajectory diffraction, that is the lens has become or we has some so we are some diffractions, the aberration lens that can also. So what a technique to overcome. So there are several structures or different techniques like boxing framing bar used to measure correct alignment. Okay. And these are placed at the die to track correct misalignment. So at the sides or the or you will find some boxes, right, box on the way, and then a similar a smaller box in the let me use another color. So this is on the wafer. They have another box that will exactly fit in the this box, and such tools are there are bars. Okay? And over it you fit another bar that exactly cover it of different thickness. By using techniques, you can overcome the problem of alignment. What I generally use is that I have in my first step I have, then for the second I have cross structure that exactly to it. Okay. So I am three over stage because okay. So for my stage another box it's a area. So such used and these are called as alignment marks that are in each mark. So when the first stage of graph not marks, but in second and third these will be useful. So in case of if someone for stage but mostly all these alignment marks are used, okay, to track alignment and such. So if it is line kind of thing, so tilted line, so that is shifted in theta direction. If it is a box fitting, so x and problem occurs. So the alignments are used, and text in box frame and bar are used alignment errors adjust according to our, and once all the box to the box the base on the bar and frame is fitting into frame, in that case we say that it is properly and then we go for the exposure. So it might be a wonder what actions have to be what kind of elements are when we're seeing it, but using marks kept at the size of the, or sometimes if what is it, small design or smaller name, one such marks are kept, so you will be able to align them using this. Fine. Any anything here? Any questions? Yeah. So, what are the advantages of projection lithography? One is improved uniformity. Since we are doing slit scanning, it is a small feature. So, in case where we need something below less 20 nanometer, in that case, we can't use there's our projection lithography. Sorry, property and lithography, but we have to go for lithography. One thing is that you can form images on paper allows for reduction in picture size. Mostly, enlargement is not that needed. Mostly reduction needed. If so, 4 nanometers on the mask and result into 100 picture on the paper. So we design a pattern according to our need. We can tailor it. So it's easier since we're doing it, then we will be able to add the so the greatest advantage of a projection lithography. What are the associated? One is it is and second is expensive. Since it has advanced optics and system cost it is due to it. Second is there are since we scaling down, scaling up and these things, there will be some element accuracy errors. So there must be design for multi sites or multi patterns. Fine. Question still. So now we come and the light propagation. Okay. So we are talking about all the cases direction something we encounter. So if we talk about and many of you might learn this medical or if you are from physics and then yes, you okay. So diffraction is based on two. One is silk and second one is so if we have a small assume other charcoal only this area. So in such case for symbiotic paper and that is a single right that creates spherical waves. So we will have highest intensity by such circular spherical patterns. Whereas if we talk about multiple where we have such two light sources entering with each other coming from these three different they will interact with even create then periodic structure or pattern like bend light structures. One dark light, then dark light followed by pattern, then again bright pattern, dark pattern. Okay. So how different occurring different lights they all on the same phase since we are talking with. So diffraction angle will depend on some things like wavelength, pitch, and power function. So a bit of different, and then we will do other types of it. Okay. So what are orders of diffraction? So in all this, the level of diffraction alpha is given sin by equals n lambda where n is the order of the diffraction. So zeroth order, the first diffraction like that. So zero direct transmission. So there will direct transmission higher order plus minus one plus two that is spread or and forms the cell bright point that is our zero. After this we are getting this pattern first order, second order. Or we are talking about lines. The word brighter point. This is our diffraction minus one. Okay, minus one. This one two. Okay. So give the direction that of our light source has like one are out and they interpret other sources if there are more than one light source. Larger pitch is fraction angle, while smaller pitch is an angle. Okay. So which is one thing which will determine our different angle. Why is about interference? Will interference means different the constructing interference that means inflection image on the wafer. So we don't want any kind of shape because we don't want some pattern that have pattern like we want something that is kind of strategy for mobile. Such things we don't. Okay. What is till now seen there the light is made coherent like a lamp laser. Then we have a lens that will obviously get the like so like the focus then will be able to make it or parallel. And then there's talking about the lens system between the mask and the wafer. So it's even this that we're talking. So the role of this different light and focuses on it. So one is that do there will be differential of height. This could be called with parallel line. That is one row. And when you scale it down, the diffraction will have more effect on feature. So what will determine how much I take care of that the numerical aperture of the lens. Okay, numerical aperture is defined as n sin theta and refractive index of the lens. It can be water or these structures are just here, but inside system or maybe they are on water lenses are there. So it will be based on that. It's not actually it's not it is E. So now that's now since not using it anywhere else, but and theta and at what angle it being so that will determine the neck aperture of lens system. Higher the aperture, it has more direction bring to higher resolution. That is, the lights will refract easily. Larger things capture more finer detail areas. So that in the mask. In case of now imaging system, it is that if we are talking about aperture, that means with the if you talk of less systems, the same pixel, same sensor, if a mobile phone and using a DSLR or such thing, you will find that there is one difference between the quality of picture. Why? Because their reference is identical aperture. Their lenses are lenses, and bigger lens means capturing more orders fine details, and that helps getting better with the same system, all is same, resolution is same, everything is same, but we'll get better images in case of a 40 megapixel compare it with 48 megapixel as a phone camera. Okay, so that's the thing is true for this case also. Or there are some advantages associated with high numeric also that there some color distortions as some color aberration, like you might see the exact color it is. So you have got image system. In this color is important, right? So what is the difference there with the result under okay. But in this case is I to lambda numerical aperture. So minimum pitch or minimum resolution R can be resolved depends on the light and the system. So we have one lens system, but about combination of the system. So the numerical will come numerical. So what are the practices that we income? One is typical different this to actual pixel are using. Theoretically, we can go very good numerical aperture. Very high numbers will lead to good resolution. In real life, it is not. Okay. There are some other factors like photoresist, baking, development. These things all determine the critical resolution that we achieve. And that's why this is depend on complete software as well as or record of will be okay. So reason aperture, yeah, in the numerical aperture actually leads to high accuracy, reducing the size and improving the image. And so actually the is bigger wafer system is again some other image point image forming on. Okay, they can see so there is no actually the photo is on the so it is just this form. So in this intensity test, somewhere intensity is high, somewhere there is intensity, somewhere low intensity, somewhere high intensity. That will mind what pattern is what formed to the forest. Clear image means if it is where we want to expose, it is complete exposure. Where we want to expose, it's darkness. Clear difference of ways. Okay, something makes the possible. We are where we want we are to be exposed or we expose it directly, and where we need the light fall. It is the it should be static zone. So it should be switched on. So say the intensity points where we want to or exposed. We want it to be completely 0 value and 60 milliwatt joule over there. Then again, addition where we want it should be at least 10 milliwatt. So this is the ideal, but not ideally it is sinusoidal. So it can be variation as like not the variation, and we will see change. Okay, is that a modulation transfer function say at 25 contrast between this of our lithography. It is the I max is the maximum minus minimum intensity by I max I max. If we are one, we say it is perfect image. Whereas if we are an empty of group, in the case we say no or the like form in this. So I if we reach 0.98 or 0.7 in this case, which will give contrast or best image
Point.
0.98 to and if we have the maximum I will give I minus I equals to 0 we get the contrast. So such points will be there. They are supposed to say they are beyond our instrument. They have become actually the maximum in the minimum intensity providing due to interference injection. Okay, so we have to have highest trust, and that was how the region we are solution. It is not just based on the but it is based on the best that it is possible. So it is perfect. It is where we have high image contrast with perfect photo contrast resulting in a star pattern. The intensity profile for step like behavior for reproduction. But the practical is that there is contrast first. So in this high contrast can use the if the non-high contrast it of such small utilities. Very high, but when it's handled 5 of the MDF. Okay, such high contrast can be used. This for the start image. So it is if we have some is the ideal, but something beyond 14 it will consider on, and some will 17 will consider as off. So the pattern is like this. Okay, in this case it will not get exposed, and in this case it will the high contrast which can it can be so that can be there. So the second or the real world case there are no image contrast. So the contrast. Okay. What happens is the pattern is with silver leading to slightly sharpness. So the that was supposed to come is actually like some in the previous class or someone was asking whether which positive get based on houses might need some different kind of so there are actually so it will so not the here after this exposure. So there will be some exposure to and then slow or some slow form. So proper and taking step can help improve the sidewall. Next things consider are the first first. So because define the range which may quality set. The first we can I like mind the system after the system and us. It should I that. But if it is not, it's small range, some variations can be taken care of. So it's like making system auto slight variation will not lead to some much problem or some degradation. But if the variation is much, in that case, will be the difference. And how focus will change? We are using the same way, same masking system, and we are going from one to another. Why does it change? Because actually the world are not that. They have value. And this is why maybe that this is focused. Some case it is focused. In some case it is over mixed variance. So it is not it should straight up. But still reasons because it might pretty flat. I'll go out and say okay. So depth is also tolerance. How much you work fine we are going or this work fine depends on depth. Optical length difference arrive different orders, and as I was saying, larger numerical aperture will our resolution, but as a larger numerical aperture increases the OPD, it is optical path, because now follow the to each point, and that is lead to defocus, and so that we cannot go with numerical aperture like optical differential it will lead to so the focus become much so we cannot have when small variations. Inequality. Now, what happens due to this offsets? And if optical points of lambda, that is the length only, so there will be no phase effect on it. But what if it is lambda? The phase difference of pi inverse will occur. So what we wanted is, and if it is the way 4 will lead to a constant and will not get creators, please. So misaligned or can lead to inverse dubbing in the ratio of pattern. So here it will like same again and again, and we can go this lambda by 2 or if or any in between. So we have to the maximum phase difference should be okay, and that is there will be no should be a part difference. There will be certain we have to it will not be misalignment of the box. So to this, what have our resolution that we are talking about? Top resolution is better on replace it. And what is technical resolution that is due to the concept particularly actually practically because we can parallelize all the phase to be some so This will correlate our mission orders and this resolution. Since currently there is ideal for layer root, the information or less variance actually allows more details and the resolution is improved. This improvement is down resolution numerical at 1 plus sigma. So that is for this partial current light. So go ahead and given by the fact and this current light income resolution. And that's why this is less because it is 1. In that the resolution is lower compared to our sequence. For the size reflecting later.
Please if I could not understand this.
But light may say in like so this is what we were expecting. But it's not so actually some issue like it will be not the social not people is not able. There will be some not and do this. What happened? We are seeing that different. That means it different, right? But which it will be perfectly the very mode. The light itself not level. This if it not well. This diffraction will decrease the rate of non-coherent or less source. So it actually leads to some in case that we get and that factor how incoherent or shear cancer will determine how much improvement actually can properly so in that case will not get this proper. Are you getting it? Yeah. Like although it gives us a bit of advantage of duration in practice. Next is surface in the when light is the photoresist. So the vapor light is hitting over when it's reflected at the air index. So I guess some reflection occurs small. Second is if we have reflex, the light bit of it is reflected. So add a here. Okay. Create and because when the exposure is straight high contrast, stand with like so get undesirable pattern, smaller pattern, bigger than such kinds of pattern. Okay. Which will add the quality of the image quality. Second is it is reflected as light is also covered. Due to the light can do non-UV exposure at the fold, like pattern roughness. So we wear something like this, a box or something like the got box, but undesirable patterns like this. First thing that we have written on the top of the as well as at peak index. So this so over there is something called as reflective coating used to reduce reflection and pushing the standing waves. 5 is when the anti-reflective was top and applied on photo. Second is anti-reflective coating. So for bar cover anti-reflective coating and top reflective coating will use to reduce reflections. This anti-coating with different reflective interface that reduces reflection. This reduces uniform exposure and size swing light. Freedom from also we will to use the coding accordingly on the reflective that using, especially in of top lighting. So what is the best reflects? So it's a condition that the reflectance should equal to different averages right the effectiveness of the subject. The thickness also be lambda or n and reflective in all pairs. Okay. So reflective index means reflective symptoms. Just state of any thickness you have and it will reflective index of just it. Next answer.
In the previous section, especially in the coating, it was mentioned as photos only. There is photoresist
Yeah. So I will some other
because in the mentioned this setting as only.
yeah, it will become the square root of it instead of
Suppose not mentioned. So that the question.
yeah. Square root of very almost.
It is what and this is substituted.
Okay. I will check maybe
Okay.
I refer to different sources. So think so the first is the convention that we so till now we have been doing all parameters to make the use on but for thickness it also with the dimension that you see that the critical dimension cannot go smaller than the this is what comes. But even if you have system making it make it of if you are reach this critical dimension, it is one problem. Okay. So we are like this because we actually the soft reflections are taking place. So that's why we are creating ARC anti-reflective cover important. It's the criticism will be for this. So without this, any photoresist significant variation with ARC and this has the critical decide sending and reflecting. All back relative coating changes the critical dimension in the processing unit. So it's not that we have to apply anything. There is a practical situation that a shopper optimization of on the index of the ARC to get out critical dimension. So we are good for perfectly optimized ARC reflective to get the critical dimension get from our and not depend on the resistance in this case. So in this ARC, that's photoresist critical. When you are it the model, you are saying.
Yeah, it's clear.
Okay. Now to some question related to our like this. Okay. Optical lithography, resolution of printing depends on mask and wave both or not both. Because the formula
Photo from the
so depend on lambda is G. Okay. Actually, therefore, is increases and upper dick or lambda is an action.
so that
Is the fact.
but lambda
So
yes,
and square, right? So then increase will lambda increase. Yeah,
optical
that's
is
fine. So what is the focus? The focus are no
I think all of that. And
yeah, it's true.
yeah,
In previous resolution made which bond in terms of spacing this with should be smaller number and larger than this by m. There should be small gap and other small dash the or the gap will be smaller than the tensor. Very
the gap between lambda and
small difference.
resolution the not proper resolution.
So that's the limiter that is the production system is high probability to a metal mask in one scanner that illuminator or in one because you are limiter scan because the mask is which one. We are talking about food
Not resolution.
resolution. And that's why it is when we are able to so it's you get all like uniformity and are the other. To get over the alignment, what measurement stars used or alignment stars used? Was frame in bar or none?
Boxing.
Yes, it is. Others.
Most
First three, all the boxing dog in bar. When the comes as a beginner, the mark, if it's boxing and such alignment quite in judging patterns is you have to align. There's been no and they are the end of the exercise. They along the structure are also maybe of any like all company of the whole doing manufacturing and remember one of the video I showed for a noise morning. So also plus the marker there. Put another layer and again it was being aligned. So this successive learning is a very useful critical. There can be both and you can sometimes might that selling micro and meter resolution might happen that one you prefer this you have a mark and a mark this side you will say it is but it will into this side. It is not overlapping. So it's very important to different to opposite. We are using this that we are using split view at the setting two different to which part of the wafer so these are two measurement and they are in box payment bar at the side thickness bar very thickness okay and they have it whatever was there before it will then the box we have the box and in the next another box but exactly side. What I started that I use I have a box and the mark same that is to be exit then I have my and what's the whole supply I will come to box because you have one of different years with different if you are in the same way then simply box forces search pattern to open the line and so just and understand also but there are some words are used right but then first of things for a lamp which sign on p and y and p and of course and db but by can summon upon is correct yes any correct this constructive the part is an integral villain the angle such as and one p and is the order of it. This is not corrected in that. Okay. Now, hit the numerical of system that equals degrees. Yes. Right.
is in a way.
60 times. Okay. So, any numerical sign and TV here will be here 100 degrees. the practical resolution projection photo range, everything is so. What is it? Practical resolution and so and the process includes the resist development, and this is a process and real one will be upon it. Here is the if the wants to align grading, what do percent like we 0 to more than 1 2 or 0 to less it should be one is and this one is 0. That's correct.
more than
Yeah, this symbol seems captured, right? Should less. This symbol gone less than 0 less than equal to and it should must equal to 1, correct? In this it has been drifted to one line spin, then it will be lower than no. Yeah, if in the then it will be the correct answer, right?
but then so we believe even
It's a symbol as some field of pulse. And then we get yes, I get
Like I want to explain that.
okay. Yeah, fill it out. Yeah. If yes, guys are like say
With the
like a point of structure, we have grade like okay. So they are filling out of the whole area. That is filled so half of it in one line is to so that means it is this meter, we can meter and then 20 meter. So this 20 micrometer computer is scaled and new computer. So it is like half is fine. One you will into spacing within a line and getting this resource if it's 20 micrometer line, the scale is 80 micrometer.
we don't have any question if let's say particularly now that is for that we have remove
To make you understand what it is. In that case, that means the lines to be at a distance. They actually want to one was getting we have larger percent fill we have so in case it might happen that seconds we have larger gap, but we make it and we not able to so there's certain back to closer and then so all
okay.
in ideal condition transfer is critic functions and stone or so that's switch on the place will be complete place on quantity
because there is
brings a sort of speed that's not a will work in so the way with all and will be in the next week so in consider in the
okay.
that's all